Good afternoon, this is Mr. Schweitzer, and continuing with a couple of practice problems on KSB and calculations of concentration. So we have calcium fluoride is the KSB, so note this is a KSP value right here, not a concentration. Assuming calcium fluoride dissolves completely upon dissolving and there are no other important equilibrium affecting the solubility, calculate the solubility of calcium fluoride in grams per liter. Okay, so again, the first thing I do is I write out my formula. Calcium fluoride goes to calcium 2 plus F minus, and there's two of them. I write my expression out. KSP equals the concentration of my calcium 2 plus ion, concentration of my fluoride ion, squared. Okay, initial stoichiometric ratio, end or equilibrium. Solid will not play a role. Again, every time I go through this process, giving myself opportunity to fill information into the tablet. What do they want me to find in order to give myself the most time to figure this out? They've given me my KSP value at 3.9 e to the negative 11th. All right, and they want me to find these equilibrium concentrations. So they want me to find this value and this value. All right, they are saying it is dissolving. If they don't tell you dissolving in pure water, you assume there's nothing else there in the problem, that there's no calcium, no fluoride present in the solution beforehand. As it dissolves, I'll gain x of this guy, and I'll gain 2x of this guy. This plus x, this guy plus 2x, and I get, in this case, plug the values in, x and 2x squared, and I get my same problem before, very similar, 3.9 e to the negative 11th equals 4x cubed. Divide by 4 and raise to the 1/3 power. In this case, we got 3.9 exponential to the negative 11th divided by 4, 9.75 to the negative 12, and then I'm going to raise it to the power of 1/3. And I get the answer x equaling 2.14 e to the negative 4th. And this is a mole per liter. This is a concentration. Now again, I want to know the molar solubility of the calcium fluoride. That means this is the molar solubility of the calcium 2 plus ions, and it's a 1-to-1 ratio of calcium to fluoride. So it's also the answer to our question is that guy. If I wanted how much actual fluoride ion concentration, I would just need to double that value for the fluoride. You'll see that because I am dissolving the calcium fluoride item, they are locked at a 1-to-2 ratio. All right, let's go to the next problem. Next problem is talking about the KSB of calcium. Actually, one more thing. I'm going to add one more thing. They wanted me to do this last problem in grams per liter. Let's do that. All right, so this guy is 2.14. Now it's moles per liter. And I want to flip this to grams per liter. So I want to cancel out moles and go to grams. This happens to be the molar mass. Now, for calcium fluoride, you need to add up the molar mass of calcium fluoride. This is 19 times 2, so 38. I'm estimating here. I don't have a calculator, periodic table in front of me, and I think this is about 40. So we're looking at about 78 grams to 1 mole ratio, and therefore 2.14 moles per liter, and that's e to the negative 4th, just times 78. So I'll take this guy and multiply it times 78, enter, and we get the answer is 1.16 e to the negative second grams per liter. Notice my moles cancels, and I am left at grams per liter. Okay. The next problem, it says we have KSP for calcium carbonate as a mineral calcite is 3.8 e to the negative ninth. Calculate the molar solubility of calcium carbonate in pure water, A in moles per liter and B in grams per liter. Okay, so in this case, we write the formula out. Calcium carbonate goes to, comes from calcium plus 2 and CO3 minus 2. So they're 1-to-1 ratios. My KSP equals the concentration of the calcium 2 plus ion, concentration of the carbonate ion, and initial stoichiometric ratio end. There's solid will not be playing a role here. It's in pure water, so there's nothing there. I'll be gaining X of this, and I'll be gaining X of this guy. So X represents the concentration of each item at equilibrium. They give us this at 3.8 e to the negative ninth equals, and then it's simply X times X. As you do so many of these, you'll find they are so much similar that kids sometimes don't like putting the work down, but on an AP exam, you pretty much got to show what you're doing. So this is going to be 3.8 e to the negative ninth equals X squared. We're just going to square root both sides, and in this case, my X equals 3.8 . Alright, this is going to be X equals 6.2 e to the negative, looks like negative fifth. Yep, negative fifth. And this would be a mole per liter. Alright, and then again, they asked you to, this is the answer to A, and they want it in grams per liter. So I just showed an example of that. It's the same math, 6.2 e to the negative fifth moles per 1 liter. I want to get rid of moles, and I want to go to liters. I want to go to grams. Grams per mole is the molar mass, and so I can erase that. So I would need to add the molar mass of calcium carbonate, and the mass of calcium carbonate I do believe is 100. So you could have, get my pen back. It'd be 6.6 e to the negative fifth times 100, and my eraser's stuck on there, so I'm just going to go, imagine that's times 100, and there it goes, times, so okay, now it's back. Okay, and that would be, get rid of my moles and go to my grams, 100 grams to 1 mole, and 100 times that would be 6.2 e to the negative third grams per liter. Okay. Again, just some typical calculations.